Hello, today we are going to be working on lesson 6.9, dividing monomials. And I want to go over just a few things before we get started. If you look at the top where it says dividing with exponents, make sure that you remember you can only divide with exponents that have the same base. So for example, this right here, because we have x to the power of a and x to the power of b, then we can divide those. The base is the x, the exponent is the a. Here, the base is the x, the exponent is the b. Since they have the same base, we can divide them, or another word for it would be to simplify it. Okay. When you divide with like bases, you will subtract the exponents in the denominator from the exponent in the numerator. Actually, that should be around. You basically just subtract them. So in this example, we would take x to the power of a minus x to the power of b. Okay. So let me show you what this looks like in our notes. All right, let's look at example 1. I have x to the power of 8 and x to the power of 3, and I have y to the power of 5 and y to the power of 4. Remember, we can only divide with same bases. So I can't take x to the power of 8 and divide it by x to the power of 4 because their bases are different. One base is an x, one base is a y. So what I'm going to do, though, is I will divide terms that have the same base. And when we divide terms with the same base, we subtract their exponents. So let me show you what this looks like in example 1. I'm going to take x to the power of 8, and I will subtract the 3, x to the power of 3, okay? This is actually dividing, and we divide by subtracting the exponents. Then I'm going to take y to the power of 5 minus the exponent of 4 in the other y. Then my next step would be to simplify it out. I now have x to the power of 5, y to the power of 1, or just y. You don't have to write that 1 there. So this would be my final answer. Now this next one, if you think you've got it, you can go ahead and try it on your own. If not, you can follow along with me. But if you do want to try it on your own, go ahead and pause the video and then come back to this. So we have c to the power of 15, and we're going to subtract 8. And then we have d to the power of 12, and we're going to subtract that 9 on the bottom. So I end up with c to the power of 7, d to the power of 3. And that's my final answer. Okay. We're now going to move on to example and practice 3. On these, we're now adding coefficients in the mix. And the easy thing about the coefficients is it's nothing more than just simplifying those coefficients and then continuing to divide the b to the power of 6 and the b to the power of 2. So when we look at this, we know that 12 divided by 4 is 3. So I'm just going to write a 3 right here. So the first thing you're going to want to do right here in step 1 is to divide your coefficients. The next thing you're going to want to do is divide the variables. So in this case, we have b to the power of 6 minus the 2. So our final answer for this one is 3b to the power of 4. Now, if you think you've got this, go ahead and try practice 3 on your own by pausing the video. And I'm going to go ahead and work on that now. 72 divided by 8 is 9. And a to the power of 9 minus the 7. And my final answer would be 9a to the power of 2. Okay. All right, moving on to example and practice 4. Now, not only do we have coefficients, but we have negative coefficients, and we're adding more variables into the mix. So we're always going to start with the coefficients. Negative 18 divided by 2 is negative 9. X to the power of 7 is going to be divided by x to the power of 3 by subtracting those exponents. And y to the power of 4 is going to be divided by y to the power of 2 by subtracting their exponents. Okay. Okay, my screen on my end has frozen, so I'm going to go ahead and stop this and reshare with you. Hold on just a second. All right, here we go. Okay, so in finishing up this one, I'm going to write it as 9, x to the power of 4, y to the power of 2. And that is my final answer for this one. Now you will see this one, practice 4 is the same as practice 3. That was just an error on my part. I made a couple of them on this worksheet, but we will fix them together. So what I'm going to do is I'm going to come up with another problem that I want you to solve. So negative 36, a to the power of 9, b to the power of 3, okay? And then that's going to be over 9, a to the power of 2, and b to the power of 2, okay? So this is the one we're going to replace that practice 4 with. Okay, so let's go ahead and get started. The first thing that we're going to do is divide our coefficients. So negative 36 divided by 9 is negative 4. And then we have a to the power of 9 minus the 2 on the bottom. And then b to the power of 3 minus the 2 on the bottom. Okay, now let's simplify this. Negative 4, a to the 7th, and b to the first power, but we don't need to write that first power. We could just write b. And so that would be my final answer. Okay. All right, let's go ahead and move to the back. Okay. Now on this one, you're going to notice after we get through example and practice 5, we have 6, 5, 6, 6, 6, 5. We need to change those. So this is example 6. And over here where it says practice 5, I want you to cross that off and put practice 6. This one right here is example 7. And then the one next to it is practice 7. And then this one down here at the bottom is example 8 and practice 8. So if you just want to change those. Okay. Now the question is, what happens if when you subtract the exponents, you end up with a negative? And based on our prior knowledge, we've learned that we can't have negative exponents. So you have to move it to the other side of the fraction bar. So if you have a negative exponent in the numerator, you move it to the denominator and it becomes positive. If you have a negative exponent in the denominator, you move it to the numerator and it becomes positive. So let's look at how this works. I have x to the power of 2 minus the 5. Okay, and when I do this, I'm actually bringing everything to the top of the fraction. So it all becomes the numerator. And then I don't do any moving around until I'm done. So when I subtract 2 minus 5, I get a negative 3. Okay, now just imagine that there is a 1 under here. There's always a 1 under there. We just don't write it, nor do we see it. Just like when we have a variable of x, we know that there's a 1 in front of that x, but we don't have to write it. Or like we just did on the back, this was b to the power, b to the power of 1, but we didn't need to write that 1. Or if you remember all the way back to decimals, that there's always a decimal at the end of a whole number. We just don't write it. Okay, so it's the same here. X to the power of negative 3, it's a whole term, and underneath that term is a 1. Okay, so what we're going to do is we're going to move the x to the power of negative 3 to the denominator, because that will turn our exponent to a 3. So what goes on top? We put a 1. Since there was no other term there, we just place a 1 there. Okay, and so this right here is the answer to that problem. Okay, practice 5 is very similar to it. So if you want to go ahead and do that on your own, you can. And when you're done, this is what you should get. 1 over a to the power of 5. Okay, we'll move on to example 6. So this is just more practice. The difference is that sometimes you're going to have negative exponents and you're going to have to move them around. So let's see what example 6 gives us. We start with 15 divided by 3 and we get 5. And then we have x to the power of 5 minus x to the power of 1. Remember, we just don't write that there, so minus 1. And then y to the power of 2 minus 4. Okay, so next what I'm going to do is I'm going to simplify this a little bit. Oh, excuse me. So I have 5. 5 minus 1 is 4, so x to the power of 4, and then y to the power of 2 minus 4 is a negative 2. Okay, the problem is we can't have a negative. So you only move terms that have a negative exponent. You don't move anything else. You leave everything else where it is. So in this case, we'll leave the 5 and the x to the 4th in the numerator position, and we'll move x to the power of negative 2 to the denominator position. So we end up with 5 x to the power of 4 over y to the power of 2. There we go. Okay, you can try practice 6 on your own if you'd like. So we have 36 divided by 4 is 9. A to the power of 3 minus 7, and then b to the power of 4 minus 6. When we simplify that, we have 9a to the power of negative 4, b to the power of negative 2. Now, both our variables are negative, and a lot of students get confused and they think, okay, well, we're going to move everything to the denominator and just put a 1 on top. Well, we're not going to do that because look at this 9. This 9 doesn't have a negative exponent, only the a and the b. So the 9 is going to stay where it's at. So when we write this, we write 9 over a to the power of 4, b to the power of 2. And we'll stop there. Okay. All right, let's look at number 7. Now 7 gets a little tricky because we have double negatives, which means we end up adding. So let's just watch on example 7, see what the process is before you try the practice. Okay, this one is also different because you don't have numerators and denominators that divide into a whole number. So when you have fractions like this, you just simplify the fraction. When we simplify 3/9, we get 1 over 3. Okay, we really don't need that 1 there, and you'll see that in a minute, but I'm going to leave it there for right now. Now what I'm going to do is I'm going to bring all of my variables and exponents on the top, and then I'll move them if I need to. So we have x to the power of 2 minus the power of 4. And then we have y to the power of negative 2 minus a negative 5. Don't forget that second minus sign, because we have a negative 5 and we still have to subtract the negative because that's the process, subtracting the two numbers. And if you recall, whenever we take a number and we subtract a negative, we're actually adding a positive. So we could change this to negative 2 plus a positive 5, and then we can simplify it further. Okay. So when we do this, we have 1 x to the power of negative 2, y to the power of 3 over 3. Now I have a negative exponent, so I have to move that to the bottom. And I really don't need my 1 there. If you want to leave it there, you can. I tend to get rid of it. So this is what I'm going to end up having as my final answer. Y to the power of 3 over 3x to the power of 2. All right. All right. Practice 7 is very similar if you want to try that on your own. And so we have 4/16, which simplifies to 1 over 4. And then I have a to the power of 5 minus the power of 8, b to the power of negative 4 minus a negative 6, which becomes plus a positive 6. So this simplifies to 1a to the power of negative 3 b to the power of 2 over 4. And then I have to move this -3 down. So my final answer is b to the power of 2 over 4a cubed. Okay, let's do the final 2 problems. We have -24/3, which simplifies down to -8. And then we have x to the power of 3 minus the power of 1, and y to the power of 13 minus the power of 6. Okay. Now, I know 8 is negative, but just because it's negative doesn't mean we're going to move it anywhere. You only move terms that have a negative exponent. This isn't a negative exponent, it's just a negative coefficient. Okay. So -8 times x squared times y to the power of 7. And you don't have to do anything with that. There's no negative exponent, so we can leave that alone. Okay. Let's go ahead and do this last one. -42 divided by 4. You're not going to get a whole number. You're going to end up with a fraction. So they're both divisible by 2. So we have -21 over 2. Okay, so we have simplified the coefficients. So now let's work on our variables and exponents. A to the power of 2 minus a -2 makes it plus a positive. And b to the power of -6 minus a -3, which is plus a positive 3. So when we simplify this, we have -21, a to the power of 7, b to the power of -3, all over 2. And now we need to move the b to the -3 to the bottom. So we have -21, a to the power of 7 over 2, b to the power of 3. All right, so that concludes lesson 9. And it looks like my screen froze again. So I'm not sure if it froze on your side, but I am going to fix it just in case you need to see the final answer. Okay, and it takes me just a minute to figure it out sometimes. So, all right. Share. All right, and there you go. So practice 8, that right here is the final answer. Right, if you have any questions, make sure you email me.